Hi guys, this is Brian from puzzleblog.com, and in Kotlin Coroutines series. Today we will continue discuss about Kotlin Coroutine, and in this part we discuss about Coroutine Context. In the previous video we discussed about suspend function. One thing you need to remember that we cannot clone a suspend function inside a regular function. In here we have a suspend function is a get home data, and if you try to call get home data inside on create methods like this, the Android Studio will show you an error. It says that a suspend function should be cloned only from a Coroutine or another suspend function. So if you want to clone a suspend function, you need to create a Coroutine, and in the previous video I also tell you how can we create a Coroutine, right? So to create a Coroutine we need a Coroutine scope, and then we can use one of two functions of Coroutine scope to launch or async to create a new Coroutine. Example, I call launch to create a new Coroutine, or I can call async to create a new Coroutine. And to get home data, you can paste this in here. You can see, okay. So what is a Coroutine scope? If you click on Coroutine scope, it's open a constructor of Coroutine scope, and you can see that to create a Coroutine scope, you need a Coroutine context. And Coroutine context has 4 elements: dispatcher, job, name, and Coroutines Exception Handler. For dispatcher, it is used to decide which thread our Coroutine will run on. Example, we can tell our Coroutine run on IO thread, default thread, or main thread. And we have a dispatcher IO, dispatcher default, dispatcher main, and dispatcher UnConfined. So for dispatcher IO, when we use it, our Coroutine will run on thread IO. For default, we use it when we want to a long operator. Example, when you want to sort a big array. For main dispatcher main, when we want to when you want our Coroutine run on main thread. Example, you want to update the data or the date for the text view. For UnConfined, dispatcher UnConfined is very special. I will talk about it a little bit later. So let me show you how to use dispatcher IO, dispatcher default, and dispatcher main. Actually, in here I create a Coroutine with a dispatcher main. So in here we need to pass a Coroutine context, right? For Coroutine context, you can to create a new Coroutine context. For Coroutine scope, you can pass one of four, at least one of 4 element of Coroutine context, or you can pass 2, 3, or 4 element. It is okay, but you need to pass at least one element. In here I create a IO scope, and I want to see which thread our Coroutine will run on. So to know which thread our coroutine run on, I will log or print the name of thread. The coroutine of main scope runs on we copy it, paste it. So now we try to run our application to see which thread our coroutine runs on. And you can see when we click on start, you can see the coroutine of main scope run on main, and the coroutine of IO scope runs on default dispatcher, and the coroutine of default scope runs on default dispatcher. It means both of them are threads IO. So in many cases, when you run on I mean when you do a task in IO thread and you want to update the status on the main thread, you need to switch on main thread. So if you are using the Kotlin Coroutine, how can you do it? To do it, you can use a function, or it's not exactly a function. You can use it with context. Example in here, we are run a task or two attack in IOS thread, and you want to update the status in main thread. You can use with context, and you pass dispatcher main in here, and do a task or update the UI widgets in here. Example in this example, we have a text view, and we call it text view data, and we want to update the status by show a text for text view data. Example, I will try to do it in here. I create a text and I assign a loading text for text view data. Example, and in here I will call a function to delay it in 2 seconds, and I will remove with context. And after delay 2 seconds, I will update the text again, and I say that request finished. And if you try to run application, maybe you will get a crash up or errors. It says that you cannot clone or update your UI widgets on iOS thread. To do it, you need to switch to main thread. And you paste it in here. And now you can try to run our application again. and you can click on start, and it will, you can see it is snip in 2 seconds, and after that it update the text field request finish. So now I will try to example. Now I will update it into use departure main, and in here I will as you know, when we use dispatcher main, Coroutine, our Coroutine will run 2 statements in main thread. So the loading text will be shown on the text view data. So now I want to switch to departure IO. And to another task example, I will get home data to get the data for home screen, and after get home data finished, I will update the text of text view data. At this point, we don't need to clone with contact with departure main, because our Coroutines code is created with a departure main. When you click on start, and you can see after 1 second it updates the text view data with the text request finish. So if I change departure main to departure UnConfined and try to run our application again, let's see one thing, and you click on start, and our application crash. So what happened? Actually, for departure main, two statements run on main thread, and with context will make our get home data run on departure or IO thread, and it's back to here, and it will run on main thread for departure main. But for UnConfined, when we use departure UnConfined, at least two statements also run on main thread. But in here after run get home data in thread IO, it back to the same IO thread again. Let me show you. In here I want to bring the thread our Coroutine runs on. Thread in I want and I will byte to, and we can run our application again and filter with flying. Click on start, and we can see, and we get an error, and our Coroutine runs on main thread, and it switch to a departure IO, and when it finished, it back to departure IO 2. So it is because we are using UnConfined. So so I think so in the case you use main, and you click on start, you can see that after at this point it gets our application will, or our Coroutine will switch on thread IO, and it's back to main thread. But for UnConfined, it will back on or resume on the same thread with it the previous coroutine or previous suspend function. So I hope that you can understand it. Okay, the next thing we discussed about is job. Actually, it is a background job, and a job is anything that's anything cancelable with a life cycle. So it just is a definition for a job. So when you can pass a job in a Kotlin scope on in Coroutines context by cron job and plus, and actually when you cron scope.launch or scope.async, it also return an instance of job, and you can see, yeah, it return you an instance of job. And maybe I will call it job one, maybe job one, okay, job one. And for async, I can call it job two, and I'll scope.async. So for async, if you use async, it will return you a defer. Actually, defer also is a job, but you can get a data from you can get a data from Coroutine by using defer. Example, in this example, you can return a string, maybe a resource, and to get an example, you can delay 2 seconds and return a string. And to get this string, you can call file results equal job to await it. Okay, because we need to clone we need to clone await function inside a Coroutine scope. So maybe I will create async a job 2 inside job 1 like this, and you can see it will await 2 seconds and get a string. It just need a defer to dash. And so because we use job to manage to manage life cycle of a Coroutine, so each job has some states. You can see in this slide. It have a state a new, active, completed, canceling, and cancelled. When you create a job, the default it will be active state. It will be in active state. And when you start a Coroutine, and job will in completing, and when you clone cancel it, it change to canceling, and it will wait on children to finish, and it change to cancelled. Or when it's complete its job or its task, it change to completed state. Let me show you example in here. We will log or print all states of the job, and to this I will clear this code, and I change job 1 to a name parent job, and I also want to log I change IO scope to main scope, and oh sorry, then a parent job, and in here we can here we inside the inside the Coroutine of main parent job, I want to create two Coroutines. Example, I call I have job 1 and I call it by call launch, and I have a job 2 in here and I call it by launch, and inside here I will delay 1 second and print job 1 finished. And I do the same thing for job 2, and I want to log job 1. What happened? Because I generate, let's see, pass a message in here. Okay, now I try to run our application and check the log. And you can see for main scope we have a Coroutines context. Yeah, HRC is a Coroutines context, right? And Coroutines context we pass a job, and its state is active, and we pass a dispatcher main. And for job 1 it is a standalone Coutines, and its state is active, and job 2 also in active state. So the default every job will be in active state. So how can we create a job with new state, and what it means? So to create a job with new state, we can push a parameter. We call it Coroutine start, and we push Coroutine start lazy, and try to run our application. You can see, and click on start button. You can see job 1 is in new state, and job 2 is in active state. So job 2 is finished, but job 1 isn't finished. Why? Because we didn't start the job 1. If a job is in new state, we need to call a function, start function, to start it. And today we call job 1 start, and we can check its state after call start function. After call start function, and try to run our application again. You can see, and click on start button. You can see here. So when we create a job 1 with parameter start and Coroutine start lazy, it is in a new state, and when we call start, it change to active state. Yeah, and now it can finish. And at this point, when our job active and become completing and completed or canceling or cancelled, Coroutine provide us a function to detect when our job finished. Maybe it can be completed or cancelled. We can check it by add a function. We call it example for I want to listener the parent job finished. I call parent job invoke on completion, and t is if t not equal it mean fail at this if we have another if we have an error in here, it means that our Coroutine or our job finished in cancelled state, and it means that it failed. Parent job fail with message. And otherwise it a succeed, it finished succeed. And now I want to try to run our question again and see. You can see when I click on start, job on start and job to start, and then parent job finished after 1 second. Here you can see parent job finished successfully. So it is the life cycle of a job new, and when you call start function, it change to active, and it do its job, it does its job. And maybe when you call cancel, it means that you cancel its job, and it become it change to canceling, and it when you await all children to finish or cancel, and change to cancelled. In here we have a parent job and 2 children, job 2, job 1 and job 2. So how can we cancel a job? So to cancel a job, we can call we have a use function cancel function. Example, in here we want job 1 delay in 2 seconds and print a log job 1 finished, but in dashboard I want to delay 1 second, and then I want to cancel job 1. I call job 1 cancel, and try to run our function again and see what happened. Click on start, and you can see when we call job 1 cancel, it cancel, and it doesn't print the log, this log, and our parent job finished. So what happens if I call cancel function for parent job? Actually it will when we call cancel function for parent job, it will cancel job 1, job 2, so now example, so in the case when we have 2 job 1 and job 2, and it is running at the same time, it means concurrency. And in the case job 1, so an exception, what happened? We can demo for this function by implement a function we call it suspend, get with index, and we pass an index is an integer, and delay we will change and at this point we will print a log for appropriate index. We'll print a log get with index and pass index. So we check if index equal 1, we throw an exception. An example in here I call get with index and pass index 1 and call get with index and path 2 is a parameter, and I try to run our mission again. When I click on start, sorry, we need to remove cancel function in here before we run our application to make sure that our job 1 will not be cancelled. Click on start button, and in here you can see that exception for index 1. It means that when we start to job at the same time, and when job 1 fail, it will tell the parent job that it failed, and parent job will cancel every children job. It means that job 2 also be cancelled. You can see that our application also crashed when job 1 failed. So how can we deal with it? So to make our application doesn't crash when one method or one Coroutine stop or fail, we need to handle the exception. To do it, we can add a Coroutine exception handler in Coroutine Context. We can call parent exception handler by Coroutine exception handler, and in here we just print the log for exception. Each we can call parent exception handler and print the message, and we pass parent exception handler in our Coroutine context by code plus. And now if we run our application again, you can see that our application will not be crashed. Yeah, it doesn't crash, right? And we can see parent exception handler exception for index 1. Yeah, so it is the way we handle exception. But in many cases, when job 1 fail, you don't want to cancel job 2, and you also don't want to cancel a parent job. How can we do it? To do it, you need to use a special job, and we call it supervisor job. To create a supervisor job, we create a call supervisor job, and to do it, we can move and launch move a job 1 to become a directly job of supervisor job. To do it, we need to, and we call it job 1 and I move it outside. And job 2, I also move a job 2 outside. So in this case, when we run our application again, you can see that job 1 will be failed, but and cancelled. Job 1 cancel will be failed and cancelled, but job 2 still work. Yeah, you can see job 1 still work and can finish. At this point, you need to remember that whenever you want to every coroutine or every child coroutine complete independent, you need to use supervisor job. But in here we also have another question: why we cannot create job 1 and job 2 inside maybe inside of main scope? As you can see here, why we cannot make job 1 and job 2 inside the Corutines scope of main scope when we call main scope.launch? Why? Let me back to the previous code and explain it for you. So maybe you ask why we cannot make job 1 and job 2 are the children job or parent job and make it fail independent, right? And because now we use supervisor job, so in the code you run the application again and click on start button, you can see that when the job 1 fail, job 2 parent job will cancel and job 2 will be cancelled too. The reason is whenever you call launch, the new job will be created. Inside here, it is not supervisor job, it is a new job. We can log the scope in here to see that we have a different job. So let me do it. We call Coroutines scope inside of parent job. We pass this and okay, so we can try to run our application again and see. So you can see here, so from in here we have a main scope and main scope have a supervisor job, and when we change to in Coroutines scope inside a parent job, it create a new job. It is a new job, it is not a supervisor job. So when you create a new Coutines in here, it will not directly children of supervisor job, so it will not be cancelled independent. Okay, so that's it for cancellation, Coroutines Exception Handler and job, and for departure, and of course it is everything for Coroutines Context. I hope that it will be helpful for you, and and it helps you to understand more about Coroutine. See you in the next video, and bye for now.